a view model. So a view model is basically a way to get live data. So what you want to do often is you have data that is shared between different parts with different activities or different fragments, etc. What you can do to deal with this is something called a view model. And the nice bit about view model is that it survives configuration changes. So if you rotate your screen, view model will stay around. And if that view model means that you're going to do quite some downloads over the internet or whatever, that is always a good thing to do, because it keeps your application nice and responsive. But we still need to make sure that if it actually disappears, we are also unregistering for listeners and not doing the internet stuff anymore, etc. So you can have your own, or you're providing your own implementation of view model. There's one requirement: a view model cannot have must have a no argument constructor. You cannot have one that has its own constructor. So, and it should not ever contain any reference to Android UI components or state or code. View model is just about data, not about UI. It provides live data objects that are then consumed by UI code that says, okay, if this changes, do this, implement this. There is one particular subclass of view model that is called Android view model, because sometimes you need access to a context. You need access to resources. You need access, even for opening a database, you need to know something. And that is what Android view models do. But Android view models do not get access to the activity. So an activity is a context. An activity is a context that is related to a particular UI element. There is another context that is not linked to UI elements. That's called that's the application. The application is independent from UI elements. So if you do things like, okay, I want to do something related to my screen density or my language or my theme, that does not work in an application context because the application does not have those properties. Just UI independent. But so if you make a subclass of Android view model, you can have one that has one parameter, which is an application object. This will be also constructed for you by default. So what does a view model look like? It looks like this. So we have a class, my view model in this case, that might have a private property users, that has inside there is a mutable live data, and that usable live data is a list of users. And in this case, we make it a lazy property. So only when you ask for this, it will actually do anything. So when you ask for it, what does it do? Well, it creates this mutable live data, and then it will also, with that object, it will then also call load users. What does load users do? Load users but it has to be asynchronous. It needs to start some other thread because you want to return the live data immediately and then load your users. Also, this is an example from the website, but I would probably pass it along the actual live data object in the load users method so that we don't have any race conditions for when does it exist, etc. Although lazy should do this correctly. So, and in the get users function, we return a regular live data. So the UI code is not supposed to change the live data. Only the view model is supposed to change the live data. So if there's a new user, it will just call set data on that mutable live data, and then every object that is registered to that live data will then be changing according to that new data. Of course, you can also have an extension of Android view model, which looks like this. Basically, you just pass in the application and pass it along to the parent, and then you have access to the application through the get application method. So if we have we have view models. How do we access these view models? That's actually quite easy. This is the Kotlin way of doing it. There is a Java way that is in the next slide. So the view model is created when the activity is first created. If it's recreated because you rotate your screen or something like that, or because it was kicked out of memory and needs to get back, it might still have that same view model if it existed, if it was not also kicked out of memory. So the easiest way in Kotlin is to use the by view models property delegate. Discussed delegates last lecture, so 3 weeks ago, 4 weeks ago, I think. Yeah, 4 weeks ago. That basically gets you that property in a nicer way. So that view model is retrieved through that method, and that view model is basically, we can get that, so it takes the type out of there, etc. So when we have the model, we can then get the users, and then we observe it with this lambda. So this is a typed lambda because it is view models are designed in Java, and it uses the single abstract method thing. So this particular syntax will create us a lambda implementation that also implements observer of a list of users. And then when we actually have data, it will call this lambda with a user's parameter of type list of user, and then you can update your UI accordingly. That's how that works. Fairly simple after you get your head around it. And so what does it look like in Java? Java is a little bit more complex because we don't have this delegate property thing. So there's something called there's KTX extensions of many of these Android libraries where they have some nice ways of doing things in a more Kotlin friendly way where possible. And there's one for live data as well. And view models. So in this particular case, what you do is need to create a view model provider, and then based on that view model provider, you get the an actual instance of that type. So it's a little bit more writing, unfortunately. And then you can basically do the same thing with Java lambdas. So that's how you do it in Java. Kotlin is nicer. And you can actually also use live data with data binding. So you just have data binding that provides this particular data. So it is lifecycle aware. So your data binding will just, if you provide it a live data, it will do the correct thing. You can even make the view model a property that is available through your activity, available as a property in your layout, and then reference that view model to get all the different components. And one of the things I didn't say about data binding is that data binding actually has the ability to basically transform getters and setters into regular property access. So if it has a get user, you can actually just access it with user, even if it wasn't written in Kotlin. Kotlin does something similar for Java-based properties, but data binding does so. Okay, so that was the data binding bit and the architecture components.